bring everything together, all right? So here is asking for Q and W for each process. You want to show the cycle on PV and TV diagram. So again, this is what I will do on Tuesday. But maybe you will benefit from seeing this before Tuesday if you want to start the recommended problems that you can already solve with the information on linear interpolation and quality, okay? So we want to find Q and W for each process. So the first thing that I'm going to do is write the first law for each process. And it seems repetitive and redundant. Or I don't know, that it's not the same thing. It seems repetitive. It's ironic that I just said it twice. Come back. Stop. Okay. I'm going to write the first law for each process. And we think, I'm just going to write it once. Why should I write it so many times? But it says that for each process, the behavior is different. So there are things that will be 0. Yeah, so we want to do it, we want to be careful with this. So we go 1 to 2, Q minus W delta U. Because we're grateful we have closed systems, first law is easy. Process 2 to 3, Q minus W delta U. 3 to 4, Q minus W delta U. And 4 to 1, Q minus W delta U. You see that. That's this side. Not bad, right? Then we see that work from 4 to 1, I wrote a comment there, it is not PV natural log of V final divided by V initial because this is not an ideal gas, okay? Then we look at those equations, conservation of energy, governing equations, and we realize that we need to find a bunch of values there that we know, that we learned how to find now chapter 3, okay? We need to find internal energy, we need to find specific volume. So that's what we're going to do. We go to stage 1, we say, pressure, we know it. Temperature, we know it. We can go to A5, so I recommend that you do that. And we see that T is greater than T sat, which means that we have superheated vapor. Now, that means that we go to table A6, and from table A6, we find U1. And we're not going to find every single property. I am looking for U1 because we see on the other side that it's one of the governing equations, okay? Sorry, that it's in one of the governing equations, so I need it. Then I could move on to state 2, but then I found V1, and I ask you why. Maybe you're thinking, you're waiting. This is the problem of not having you in front of me, but I am looking for V1 because I see the behavior. From 1 to 2, I have constant volume, okay? Because if I look at 2 over there, I have 600 kilopascals, and that's all that I have. 600 kilopascals. I need another property in order for me to find U2. So I will say that the other property is V2, because V2 is the same as V1, okay? So I find V1 on table A6, pretty straightforward, not bad. So then I move on to state number 2. And I'm going to look at the other side again. Do I need to find information at state 2? Because maybe I don't. It looks like I do. I need to find U2. So I have that the pressure at 2 is 600 kilopascals. V2 is V1. And if I go to my table A5, I see that V is greater than VG. That means that we have superheated vapor, which means I will go to A6. And for 600 kilopascals and that specific volume, I do not have that value on the table, which means I have to do linear interpolation. So I do it, and you see it there. I did linear interpolation, and you should practice doing that. I know I'm sending it to you, but you should still practice doing that. And I can solve for U2, and I'm solving for U2 because I need it, all right? I need it for my conservation of energy equations, okay? Then I move on to my state number 3, which is pretty straightforward because I have the pressure and I have saturated vapor. Excellent. So it's just going to table A5 and finding V3 and U3 because both of them are on my governing equations. However, you're going to see a few comments there. It says, let's go to the diagrams and let's start drawing those diagrams, okay? 1 to 2. Let's just look at 1 to 2. I know there's a lot going on there. First of all, I don't know why it says no up there. 1 to 2, they are both superheated vapor. That's the first thing that I'm seeing. So I'm just going to look at 1 to 2. I'm not going to worry about the rest of what's happening there. 1 to 2, superheated vapor, pressure increasing. So look at that diagram and make sure that it makes sense to you, all right? On the TV diagram, we have constant pressure lines, all right? So it's going up, constant volume. On my PV diagram, obviously it's going up and it's constant volume. So 1 to 2 are both the superheated vapor region. So on this side over here, okay? And this side over here, all right? Where the volume is the same and the pressure is increasing. Now 2 to 3. From 2 to 3, we have constant pressure and it's moving to saturated vapor, okay? So we have constant pressure on this side, and you can see it on your notes. It will move from 2 to saturated vapor at constant pressure. So we have a horizontal line. But on the other one, on the TV diagram, we have constant pressure, which are these lines. So we'll move from 2 to saturated vapor following a constant pressure line. So 2 to 3, there's some questions there. What can we tell about T3 and T2? We'll go over that on Tuesday, as I said, okay? Then we look at our governing equations again, figure out if we need information about 4, and we do. So what do we know about 4? 4. We know that V3 is V4, right? V constant. And we know that T1 is T4. Guess what we have, all right? So what we have here, okay, is enough information. 2 properties that are intensive and that are independent of each other. We go to table A4 at 150 degrees. We have our specific volume. It is the same from 3 to 4. That is part of what's given, right? Constant volume. And we see that it's a saturated mixture. So make sure you have the tables and that you practice that. Because it is a saturated mixture, we'll have quality between 0 and 1. So now from 3 to 4, we have constant volume. So it could go up or it could go down. We know that from the temperature, it will go down, okay? And we know that from 4 to 1, we'll have constant temperature. So we know constant temperature is this way on this table. But we know that constant temperature are these lines on this diagram. Not table, diagram, okay? So we need to move following these lines when we have constant temperature. So the good thing about this example, what just happened here? The good thing about this example is that it has multiple processes. So first of all, let's do one at a time, one process at a time. If we know the behavior of that process, we can get information about the second state if we don't have enough information. If I tell you we have pressure and temperature, we have constant volume, we only have internal energy at the end. Then you can have internal energy and specific volume. The behavior will tell you how to find the property that you don't have, all right? And here we do it 4 times, that's it. We just do it 4 times. And we have our equations of conservation of energy and work. And looking at those equations, we determine what do we need to find from the table. So I need to find specific volume, I need to find specific internal energy. Maybe I don't need to find anything for some of the processes. Maybe it's 0, maybe it's only asking me for work if it's constant volume. So we need to figure out what properties we will retrieve from the tables. So we will do this again, all right? Or we will do this starting from the very beginning on Tuesday. And as I said, on Tuesday afternoon, the solution to the recommended problems will be posted. On Monday, there will be no class. This is what I had left, all right, for today's material, today being Thursday. So just make sure you understand. On Monday, I will be in my office from 11 to 2. I'll be grading your exams. Hopefully it's higher than 80 and, and I'll be working on accepting or not accepting, hopefully just accepting proposals, and then I'll be answering questions on this. Just make sure you understand this, all right? On Tuesday, we're going to do that example, and then we're going to use other tables. We're going to practice tables for ideal gases, which are completely different, but we'll still use Q minus W delta U, all right? So hopefully it makes sense. If it doesn't make sense, I can do a lot of this again on Tuesday. Just make sure you do your part, and I'm really happy with the class so far, like with you guys. So I will see you guys tomorrow for the exam, depending on when you're watching this. Bye. Where do I stop this?